Everyone, today we're going through the March SAT predictions, and before we get into the predictions, make sure you guys subscribe to our free weekly newsletter. We're going to be dropping tips every single week on how to score 1500 plus on your SAT, but alongside that, we're going to have curated lists of opportunities like summer programs, extracurriculars, all that mumbo jumbo. So if you want access to that, make sure you click the first link in the description. But enough of that, let's get into the question. So it says, well, I guess the prediction, the first SAT math prediction, it has to do with geometry. It's a hybrid between percent increases and ratios, so it's super interesting. So let's dive into the problem. It says the square's sides are increased by 37%, resulting in an area that is equal to that of a rectangle with a 2 to 5 side length ratio in a perimeter of 24 units. Find the area of the original square and round your answer to the nearest tenth. So there's a lot to unpack here. The first thing I'm going to do is focus on this first part. The square sides are increased by 37%. When we see a percent increase, we're going to use the formula 1 plus r over 100. In this case, r is going to be our 37, right? So if we have 1 plus 37 over 100, we get 1.37. This serves as our scale factor, right? So we can apply the scale factor to the side length of the square to find the length of the new side. So let's say we represent the original square side as s, right? And so then we can just apply this 1.37 to the front as the coefficient, and now we have the new side length of our new square, right? But the problem says in the next part, resulting in an area that is equal to that of a rectangle. So the area of the new square is equal to the rectangle's area. And so to find the area of a square, we just do, side times side. And all the sides of a rectangle, all the sides of a square are the same length, so we can just square this value. And when we set this equal to the area of the rectangle, which we do not know, but right, so what we can do here is actually set up as systems of equations because this is a fixed ratio, right? So then we can write this as 2x plus 5x. And what we're essentially going to do is solve for x by setting this entire equation or expression equal to the perimeter, because once we're able to find x, then we're able to actually find the length and width, multiply those together, and then set that equal to the square's area, if you can see where we're going. So I'll explain this. So we have 2x. What does this represent? Well, if you think about a rectangle has two sides, the width and the length. So in this case, the shorter side, 2, is going to be the width. So this is the width, and pretend this is the length, right? And then we're going to set this entire thing equal to the perimeter, which is 24 units. But what is the perimeter? The perimeter is the sum of all the sides of a rectangle. We only have one width and one length right now, and so we need to multiply the entire thing by 2. There we go, and now we can just multiply everything out to solve for x. So we get 4x plus 10x. Oops, okay, just pretend that's 10x equals 24. So that's 14x equals 24, and so x must equal 24 over 14. So what do we do with this value of 24 over 14? Well, pretty simple. We plug it into 2x and we plug it into 5x to solve for the actual value of the width and the length. So we have the value of our width and length, right? So what do you do from here? Well, we need to find the area of the rectangle, right? So we can set it equal to the area of the square. So we just multiply these two fractions together and simplify that, and we get a value of 1,440 all over 49. All right, cool. So now we just have to solve for s squared because we're trying to find the area of the original square. And so because s represents the original side length, then we want to find s squared because that's side times side equals the area of the original square. So this right here expression, 1.37 squared, that's kind of 1.37 s squared is the same thing as 1.37 squared times s squared equals 1,040 over 49. So I'm going to save a couple steps, divide both sides by 1.37 squared, and then we have our answer. So in this case, s squared is equal to approximately 15.65, and you got a bunch of decimals after that, but we want to round to the nearest tenth, and therefore our answer in this case, s squared, will be equivalent to 15.7 as our final answer. All right, so let's move on to the next SAT math prediction, which actually has to come from a similar question in a Blue Book practice test. Right, so this one is similar to a question from Blue Book practice test number 7. It says a right circular cone has a slant height of 97 centimeters, and the area of its base is 5,329 pi square centimeters. What is the volume of the cone in cubic centimeters. Okay, let me switch colors here. Okay, so what is the first plan of action? Well, we're given a couple things. We're given the slant height. So you might be wondering, what is the slant height? Well, I have a nice diagram here. You can see, oh god, green does not show up well there. I'm changing my colors to pink. So this right here, this L labeled is the slant height. Okay, so your actual height is this, right? H, that is just the actual height. But your slant height is referring to this value out here. You'll recognize that the slant height actually makes a right triangle with the height and the radius. And so we're going to utilize that to find a couple values in the future. But the first thing I want to do is actually find the radius, right? Because currently we don't know the radius, but it's pretty easy to find. So the base area, which is given, is equivalent to the pi times r squared. So what is the base area? Well, it's given right here as 5,329 times pi squared centimeters. So 5,329 pi equals pi r squared. So r squared. So now, how do you find r? We'll just isolate r. So this case, r will equal to 73 centimeters. Always have to do this, just be cool. All right, so now we can actually utilize this right triangle, I guess, relationship. So we know the, oh god, I have to change back to pink. So we know the radius, right? Our radius here is 73. Our height is a unknown, so that's what we're trying to solve for. And we know our slant height is given as 97, and we referred to the slant height as just this L right here. So that is 97. So now we can use the Pythagorean theorem, a squared plus b squared equals c squared. So let's set that up. So if you want to write this as an expression, it'd be length equals r squared plus h squared. So this is not actually the length, that's the slant height. But we know the slant height, which is 97. So 97 squared equals 96 squared root, which is 9 squared. This side's r, makes 3 squared plus height squared. Right, so we subtract 97 squared and 6 squared both sides, we get the height equals square root of 4,080, which gives us 64 centimeters as the height. Okay, so now we have the radius and now we have the height. What do we do from here? Well, we just use one last formula, which is the volume of the cone. So the volume of a cone is equivalent to 1/3 times pi r squared times height. And so now it's pretty easy to find the volume because we know the radius, which we found, and we know the height, which we found here. So 1/3 times r, 73, square that times h, height, 64. All this is going to be approximately equal to 113,685.333 pi. And so we get a decimal, but of the answer choices we have, it lines up pretty nicely with answer choice C. And so that is our answer. For our next set of SAT predictions for the English section, it's going to be these quote-unquote bait note questions. So these are rhetorical synthesis questions, or the student note card questions, however you like to call them, where essentially now you actually have to read the notes, right? Instead of just skipping down to the question and then just picking the answer that best describes the claim. But the strategy I like to use here is just go through with your normal strategy. And what you're going to find is usually you're going to be ending up with two questions or two answer choices that both establish a relevant claim to the question, but one of them is going to be either factually or infactually correct. So let's get right into this example and we'll see what we're talking about. So it says the student wants to indicate the California red-legged frog's WS classification category. Which choice most effectively uses relevant information from the notes to accomplish this goal? All right, so we want to indicate the specific FWS classification category. All right, A says species on the FWS list, that's hard to say, I'm just going to skip it from now on, which includes the California red-legged frog, are classified as either endangered or threatened. All right, so this is a problem, and it's not A because it says it's classified as either endangered or threatened. We want a specific classification, which A does not give us. B says the California red-legged frog appears on the FWS list of at-risk species. That could be a potential classification until you read the first bullet, which says the U.S. Fish and Wildlife Service keeps a list of all at-risk species. So everything in here is a list of at-risk species. So it's not a specific classification and therefore it cannot be B. C says according to the thing that California red-legged frog is in the endangered category. in danger of extinction throughout most or all of its range. So here could be a potential answer, right? Because it is making the claim that it's in the endangered category. D says likely to soon become endangered. The California red-legged frog is classified as threatened. All right, so this says it's classified as threatened, while this one says it is already in the endangered category. D also says it's likely soon to be in the endangered category, so we can make a comparison between these two claims. Is it endangered, or is it likely to soon be endangered? Well, let's read up here. It says species on the list are classified as either endangered or threatened. Yeah, we know that. Species that are in danger of extinction throughout most, A species that is likely to soon become endangered is classified as threatened. Okay, interesting. That could be relevant for D. And this last part says the California red-legged frog is likely to soon become endangered. All right. So that means that it cannot be answer choice C because it is likely to soon become endangered, which is directly stated in D. All right, so for my final SAT prediction for the English section, that's going to be these text structure and purpose questions. And the reason I included this is because a lot of times students treat this as one of those long paragraph questions where, they get really caught up in it and it takes a lot of time. But if you really boil it down, these should go as quick as your grammar questions in some cases, and I'll show you why. All right, so mathematician Claude Shannon, blah, blah, blah. All right, so this part right here is just like introducing the person, right? We can see here his most important paper is a mathematical theory of all this, and it just goes on to explain what the paper is about. But because I'm not actually interested in the information, grabbing specific evidence from the text, I just want to describe the overall structure. All of this right here is just nonsense that I don't need to know. Okay, so what I have right now is we have this famous mathematician. He published a very important paper that did a bunch of cool stuff. Okay, now let's see what the next sentence says. It says Robert Gallinger. So we have a different person now. It says one of Shannon's colleagues said that the bit was Shannon's discovery, and from it the whole communications revolution was sprung. Okay, so this is interesting. So this is another perspective, right? So another colleague or researcher or mathematician, whatever, take or perspective on Claude Shannon's work. Okay, so which choice best describes the overall structure of the text? Without even looking at the answer choices, what I have is famous mathematician introduced, famous work that he had introduced, and then some other researcher's commentary on his work. So A says it presents a theoretical concept, illustrates how the name of the concept has changed, and shows how the name has entered common usage. This makes absolutely no sense, right? So what theoretical concept is being introduced? None. We have a mathematician being introduced, so it's not A. B says it introduces a respected researcher, so it lines up, right? A mathematician is a respected researcher because it always says foundational figure, okay? Describes the aspect of his work. The important paper is the aspect of his work, and suggests why the work is historically significant. All right, so does it suggest if it's historically significant? So what we have here is a researcher saying that his work was, and from it, the whole communications revolution has sprung. That sounds pretty significant to me historically, right? So I'm definitely leaning towards B, but let's read through the other answer choices. It names a company where an important mathematician worked, details the mathematician's career at the company, provides an example of the recognition he's received there. So this is really narrowing the scope, right? Our intro talks about the mathematician and how he's a really foundational figure, but it doesn't mention the company that he was employed at, Bell Labs, until the second sentence, right? And so C is really trying to push you towards, his career at that company, which was literally just mentioned by name and nothing else. So it cannot be C. D says it mentions a paper, offers a summary of the paper's findings, it presents a researcher's commentary on the paper. This is probably the strongest distractor answer, right? Mentioning a paper, which it does up here, summary, which it does, and presents a researcher's commentary on the paper, which, you could say it does offer that commentary, but I would say that this answer right here, D, is not as strong as B for this reason, right? You have to understand that when it says it presents a researcher's commentary on the paper, this entire answer choice is really focused on that paper, right? And while a big portion of this excerpt does talk about the paper, what it's really getting at is praising Claude Shannon as being just foundational figure in informational theory, right? When Robert Gallinger, the colleague, says Shannon's discovery, so this is the only mention of sort of attributing it back to the paper, and from it the whole communications revolution has sprung, that is really giving all the credit to Claude Shannon instead of specifically critiquing or praising what's in the actual paper, right? And B just works so much better with it, introducing that respected researcher, which D does not, right? D just says straight up, it mentions the paper without mentioning, the most important part, the main character in all of this, which is Claude Shannon. Therefore, our answer choice here is going to be B.